Hi everyone, Nick here, Solutions Architect at Databricks. And today I want to give you a hands-on demo based on a predictive maintenance use case and showing you how to build this on the Databricks Intelligence Platform. And before we jump in, let's have a look on how the current data state is looking like. So you can see it's often still very fragmented. So we have a data warehouse out of the past where we did analytics and BI on top of it. But then we realized if you want to do machine learning or also process unstructured data, we might need a data lake, for instance, on one of the hyperscalers, Azure or AWS. Where we have relatively cheap storage accounts. And then we also use some other tools for doing governance, orchestration, data science, and also nowadays generative AI. Well, and this fragmented estate makes implementing new use case sometimes also quite complex and also produce high costs. And you, for instance, on data warehouse might also have proprietary formats. Well, basically, if you're looking on data and AI leaders, what they have in the mind nowadays is really simplify, consolidate the different tools, vendors, and architecture they currently have. And well, at the end, making future-proof, avoid lock-in, and even think about multi-clouds nowadays. And well, another topic is also balancing autonomy, well, having also governance. And well, at the end, we want to ramp up with more data and AI and BI topics on the platform or on our data landscape at the end, without having also this incremental cost factor. So more data, but not proportionally more cost at the end on the landscape which we're using. So, and that's where the data intelligence platform is coming in. So what does data intelligence means? We bring a platform for unified data and governance in there. And well, and tune AI into it. So for the daily work, we are bringing different AI features into it, like a assistant who supports you if you have bugs or want to discover your data. As a short example on the platform. And you're going to see it live as well in a bit. So unifying in on your data, as we already see, is like really important for the people. So we want to reduce unnecessary costs for copying data around. We already saw it, data warehouse cannot do machine learning. So we copied the data in the past to achieve that. And of course, you want to break out of proprietary formats, no lock-in. You want to use open formats, and that's where low-cost data formats come into place, like Iceberg or Delta Lake. So on the one hand, the same format can be consumed and read for AI and machine learning purposes, but also like for normal data engineering, analytical purposes, or for any data sharing. And well, it also provides features which you usually only had in BWs or SQL databases, which you at the end can save on cheap storage spaces on the cloud providers like Azure, GCP, and AWS, like doing merges, having asset control, updates, deletes, etc., and other benefits which those formats are bringing to you. Well, at the end, it's also important to get the data into the platform without any hassle. There we provide, for instance, a Databricks Lakeflow, which supports you in there. On the one hand, we have something called Lakeflow Connect, managed connectors for different databases and other servers like SAP Salesforce, Google Analytics, and of course, any flat files lying around also in our storage accounts in the hyperscalers. Then you want to reliably do your transformations on those raw data using, for instance, Spark declarative pipelines. That's where for SDP stands for. And then you want, of course, orchestrating your workloads, not only your ETL process, but also any other analytical workloads like report, refreshment, and of course also the monitoring using Lakeflow jobs. Well, and the other topic in the puzzle is governance and also understanding your data. So that's where Unity catalogs coming into the game. Traditionally, catalogs cover only access control and auditing, but Unity catalog without manual effort also makes it easier for you to discover the data and collaborate. Of course, setting up the access control easily, creating lineage and quality monitoring, and also set up your cost controls or even your business semantics on it. And so, well, this is like the whole governance layer, which you have on top your open formats, Delta Lake and Parquet, or Iceberg at the end. Well, and if you're looking on the services which we have on top of it, we have Mosaic AI for artificial intelligence. Those are our AI features. Then SQL warehousing, like a serverless interface on top of your data. So basically, compared to your business warehouse, you're actually just paying whenever you use it as an interface for your reporting, for instance, and not constantly paying for it at the end. So we have Lakeflow as already seen, and then AI BI as a business intelligence solution on our platform. And so, well, if you look at some features, adding to what I just showed recently, we also have something called Lakebase as well, a managed transactional database on top of Postgres, especially in generative AI use case. Nowadays, we realize, okay, sometimes we need those benefits of doing transactional reads and writes. So then, well, also, if you think about agents, you might want an app to on top of it to use it, leveraging the generative AI or your agents functionalities at the end, or also for very specific reports or any other applications. It's helpful. So you also find managed apps on our side, and at the end, the marketplace to share your data within your organization, but also outside of your organization. A short overview, data warehousing. So we really have a warehousing solution now, which can be 10 times faster than alternative solutions, with also lower cost and at the end, quicker answers. Well, which you just connect to your data, and then you can set up your reporting, well, most beneficial way in a serverless way. And well, at the end, we have also a dashboarding solution and also something called Genie, where you can really ask questions about your data and visualize your data by yourself, or leveraging external tools like Tableau or Power BI or any other services to connect to your data at the end. Oh, and at the end, we also talk about agents. So really, you can find the most complete agent system on our site. Agents that reason over your data at the end, well, and support you for all existing future AI models. So one platform where you can leverage all your AI models at the end with guardrails, evaluation options, and monitoring built on top of MLflow. Let's come finally to a use case. And today we're going to talk about a company called Echo Energy. It's a wind farm management company. And well, Echo Energy operates, well, wind turbine farms across the world. So they want to use data and AI to, at the end, maximize the energy output and also increase, well, at the revenue. And that's like one of the challenges. So they want to reduce outages to, at the end, have a higher revenue. And well, they also want to centralize the data needs on an IoT platform so that they can more efficiently monitor and also detect faulty turbines for predictive maintenance. Well, across the whole business at the end. And well, why Databricks? It provides them an easy way to build dashboards, ingesting all the data in real time to feed those dashboards. Well, and at the end, they can also add the AI layer to proactively detect those anomalies, trigger maintenances, and well, at the end, maximize the asset utilization. And well, let's have a look on the personas, first of all. Usually you have like 3 personas: a data engineer, which mission is to ingest and transform the data efficiently and also reliably, and so, well, of course, also ensure data quality and monitor those ETL pipelines. Then you have like Mark, the data scientist, who at the end wants to build and deploy the ML models on top of it, or even, well, data scientist / Gen AI scientist or engineer, also building AI agents on top of it, so where you can communicate and get insights how to do the repairs, for instance, in this case. Well, and then Alice, SBI analyst, her mission at the end is to extract insights into the data, for instance, building dashboards, and at the end, empower the product teams and the stakeholders with that. And of course, everyone needs also one platform where they can easily search and gather and discover the data in a really high quality, where Unity Catalog also plays a role. And well, accordingly, we're gonna go through the whole process chain. So we're gonna start ingesting, processing the data using Lakeflow declarative pipelines in this case, discover the data in Unity Catalog, which we ingested afterwards. Then we want to predict turbine anomalies using ML models, or also generative AI agent supporting the mechanics or the engineers who are monitoring the turbine farms to ask questions about the current state of a specific farm or turbine. Then we want, of course, to build a dashboard or establish a so-called Genie space to ask questions using English about our current turbine state. And then at the end, of course, we want to orchestrate a monitor or ETL workflow and analytics workflow that it's stable, well, and so recurringly refresh the data. So now we are on the data intelligence platform. And before we're gonna dive into it, let's give you a short overview. So here on the left side, you basically see a generic category where you see something like workspace. That's what you later would save your files, which you generate, your dashboards, your SQL queries, etc. You have the catalog, where we're gonna jump in a bit, where you can do your governance. You have your compute. That's like at the end, the warehouses and well, cluster you'll be using to do your ETL and warehousing and machine learning. You have something called jobs pipelines, which is rather something which a data engineer would use. But so where you do your orchestration, you ETL pipelines at the end. Then we have something where mostly data analysts gonna be there. So an SQL editor, writing queries, building your dashboards, building your Genie spaces to, well, use text to answer questions about your data. Also here building your warehouses as interface, which can be used for your reporting and analytics use cases, querying the data in a well, business warehouse-like way at the end. Well, then data engineering, you see your runs and, well, performing your data ingestion plus the jobs and pipelines, which we already mentioned in this case. And then AI, ML for the data scientist and or generative AI engineer, a playground for your Gen AI models, building your agents, performing your machine learning experiments, do your feature engineering, well, creating your models using MLflow and serving as endpoint to your machine learning models or generative AI agents to be further used in your applications. All right, let's jump to the catalog using Unity Catalog, and I'm jumping straight away into a schema, which I already created. So important for you to know, first of all, you have a 3-level structure here, something called catalog, similar to a database in SQL server. Then you have a schema, and then you have tables. And beside tables, we have also models for machine learning models or LLM models you created. and also volumes for your unstructured data. That's actually where we're gonna jump in here. So we have here, for instance, we simulate here the incoming data for turbines. So we have the historical data. Here's Paquet, the incoming data, some maintenance guides in PDFs, some information about our turbines, and also parts. So for instance, here you can see, okay, we have some PDF files in there. Here you're gonna find the incoming JSON files, etc., etc. So, and those files now we're gonna be using as an input to process them now with our declarative pipelines. So how do we access them? So first of all, theoretically, you have here the ingestion pipeline to use Lake for Connect, and so ingesting raw files is also part of it, but you can directly do it in ETL pipelines. And here for later, you have also the jobs for orchestration. So normally you would go here, define your name, your catalog, your schema, where the table is going to be default safe, which you're creating. And then you can also define some schemas to do that. And I created a pipeline for you in this case. That's this one here. And you can first of all see that you have a really nice graph showing exactly where what happens. So in this case, we see on a high level, we have our sensor bronze data, which come regularly. We have our turbine data, some information for that. So first of all, what you can see is a beautiful graph showing your workflow of the different tables you're creating. So you can see here our raw tables, the turbine information, the sensor bronze data, and historical data coming in with a so-called streaming table. Which is good for only incremental loading and streaming, as the name already mentioned. And then we have something called materialized views, which is actually also a table, but it does incrementalization, manage in the background and leverage it afterwards for your further aggregations and transformations. So in this case, we aggregate the sensor data with different features on an hourly basis. We can also see here the schema points. So we see the turbine ID, some different features, standard deviation of the sensor data and the percentiles. And then we create our training data set out of those tables. And also for the inference, we create our current features. And then, using a machine learning model, we are getting our current status of all the turbines. So besides the graph view, you also have here the list view. And here you can see also some more details about the tables. For instance, how many data has been outputted as a target, what's the duration of the table, and also which expectations have been met or not met. As an example, here on the sensor bronze table, we can see that our correct energy has been dropped because apparently there have been null values or wrong values here, and you want to, of course, adhere the quality of your data. And that's something you can do with those expectations, which you also define in your SQL queries when creating the tables. And what you usually would see is the edit mode, how you're adjusting the data. So if you go here to transformations, we see here our bronze tables, which are the 3 tables: historical turbine status. You can add a comment here for Unity catalog at the end as well, that you have some documentation about the data. And you see with a very simple function, we put here the path to the volume and the format, which is in this case JSON. You can stream the data into it. You can also set some constraints for expectations. If they're not fulfilled, you're gonna get other warnings, or you can also delete the data if you don't want them included here. So for instance, here you have on violation drop for our sensor real-time data. And similarly, you do it for all the 3 data sources. Then we do this some transformation of the silver layer. We saw that we have our hourly sensor data in this case. So yeah, here we do some more complex calculations. I don't want to dive into detail afterwards. And well, here we leverage at the end to do our inference. So we create our current features for inference with some transformations here, leveraging the current sensor data and also the and also the turbine information which we have here, just taking the last status actually, because sensor data coming continuously. So we just want the information of the last one. That's basically what's happening here in the last row. And based on the current information we have on our sensor data about our turbines, we then leverage a machine learning model, which is behind this function, to get our prediction. And well, those data is at the end saved. And here we have also training data set for retraining our model at the end. And here you can also deep dive into the table. So if you want to check the historical turbine status, we basically see here how the table is looking like. So we can do it straight in the platform, and also the graph is developed for us doing execution testing here in the background. So now with that, a data engineer managed, well, with a very relatively simple syntax, in this case SQL, you can also use Python to set up their data engineering process. And well, besides the machine learning model, which we're gonna create together in a bit, they're able to create a pipeline, getting the raw data in, transforming it for the needs, in this case for machine learning, but also for the reporting, even executing a machine learning model in this case in their ETL pipeline, and at the end have the gold tables to be later on consumed by the analysts, by reports, etc. All right, with that, let's jump back to our overview of our pipeline, and let's take this shortcut to get actually to our governance solution Unity catalog. So we're here in the same schema we have been before, and well, we see here our sensor hourly table, but well, we want to take the final table which we have, the turbine current status. And first of all, what you can see here is in Unity Catalog, you can see how the table has been created. So this makes it really easy to understand how the data has been generated. You can see here the table. You can see the description which we created here with this command option. Alternatively, you can also use generative AI here to adjust this text, or you can do that also for the columns. So we can, it takes a few seconds, and it hopefully gonna generate some really nice descriptions in this case for our table columns. So there we are. For instance, identifier for each wind turbine, allowing for tracking analysis of individual turbine performance. Wow, sounds good. In this case, let's assume we like all the descriptions and we're gonna save them. Next, what you often want to do is, okay, just have a small batch of data to have a look how the data look like. So in this case, we have a turbine ID, a timestamp, and different features like the standard deviation of the sensor, latitude, longitude of the turbine, etc. And of course, our prediction if, well, some fault is there or not. So in this case, we have some fault in sensor B or F, or other turbines are just okay. Then details, that's a little bit more technical. We can see it's a materialist view. You can see also some properties and configurations, which rather a data engineer would look into it. Well, and as it's a materialized view, you also know it's saved on your storage or in the Delta format at the end, in this case. Then you can set up your permissions. So for instance, I can select and choose all account users or specific account users to be able to query the data, or I can also give all privileges, and I can even adjust or refresh the data with our pipeline. You can also set up here more complicated policies using row level or color masking here, which I will not deep dive right now. That's something for a separate session. And well, you can also see the history of the data. So Delta can leverage time traveling. And well, what's also pretty amazing, you can also see the same what we saw also in declarative pipelines, to see a whole lineage graph around the tables which have been used. So you can really understand where your data is coming from, and across multiple pipelines you're creating, and also across other types of views, machine learning models, and so on. In this case, we only have tables and materialized views, but this would be also interesting. For a data engineer, also data analyst, to understand where the data is coming from, to understand it. And also, like here, you can also easily detect, okay, where specific columns are even coming from for each table. Afterwards, you also have the insights. In this case, I haven't executed a query. We can have a look afterwards. Here, just some backend query has been created, but once you run queries in your warehouse, you're gonna see also how the usage data is. And you can also enable something called quality monitoring here to perform anomaly detection or data profiling, creating the different metrics regarding your data quality, or also like your freshness of your data, to auto detect if, for instance, data is not coming on a daily basis anymore, but a weekly basis instead of an hourly basis, on a daily basis, as an example. So that's Unity Catalog as an overview. One topic I also forgot is you can also add a text to mark the data and leverage them at the end also for your policies, or on a table level. Well, and all those functionalities at the end make the life for a data engineer, data scientist, and data analyst at the end easy to discover the data. And at the end, you can also use a functionality up here to search, and use also English to search for the relevant data assets you need at the end. All right. Now, before we're gonna jump and create our machine learning model, let's have a quick look in our training data set. So we see a lot of features, the sensor information, energy consumption, some other standard deviations about the sensor data and percentiles. And then at the end here, we have also our target column from the historical data, abnormal sensor, which sensor is abnormal, or if the sensor is okay and there's no abnormality, which means there will not be any maintenance needed for a specific turbine in the future. And now let's see how we can create a machine learning model using this training data set to predict any potential maintenance topics or issues in our turbines. So for that, we go to experiments, and we have here the option to do classification. So you have different options here using AutoML in the background, and we want to do a classification in this case. We choose our cluster. We are browsing our catalog where the machine learning model is gonna be saved at the end. So we have main, and then Greek IoT, and sorry, where the data is coming from, of course, and we are taking the training data set. Well, we can see here the schema, which we already looked like. And well, we gonna choose our abnormal sensor as predicate null. We also define an experiment and we'll click Start AutoML. I can avoid it in this case. So basically what it's gonna do for you at the end is creating an AutoML experiment like this one. Here we simulate a bit because we took directly light GPM, but normally you would see like all your experiments or models which have been selected by the AutoML functionality, and then you can choose pretty much the one with the best accuracy, for instance, here with a 1 score. So in this case, we say, okay, we want to take light GPM. The beautiful part about it is you get well, good overview of all the statistics or metrics, which it has been evaluated using MLflow. Also here you find some more visualization about model metrics and also the artifacts behind it. And AutoML also generates your notebook that you can basically well, reproduce your machine model and do like the adjustments based on that afterwards. So, and then the last thing is, we already did it, but theoretically you would also re-guess the model then in Unity Catalog. There you see, again, the whole governance layer centrally available for you to manage also your machine learning models. Here we already can see it. So we can see here the registered model, also the artifacts behind it. And if you go one level up, we can also see that we can manage different versions of the model, and we also can serve the specific model. I already have done it for us. So basically, if you click on serve the model, you give it a name, you define if you want CPU or GPU compute, you also define the scaling in regards of concurrency. In this case, I'm going to serving endpoints and gonna search for IoT, I called it. It's now in the meantime already ready. We can see that we use this model version 2 in this case. I haven't run any queries yet, but we're gonna do it together in a bit. For instance, using a generative AI model or your inference pipelines to, well, use this endpoint to get the data in pretty much real time, the prediction afterwards. All right, now we created our endpoint for machine learning model, but at the end, what we want to generate is some kind of agent which gonna help a mechanic or the engineer who's monitoring So at the end, now we created our endpoint for predicting if a turbine might need some maintenance or not, or might have a default in future. But actually what we want is for a mechanic or an engineer who's monitoring the turbines to have some kind of agents helping them. And so, well, this agent we're gonna build together now, and basically it looks like that. We, first of all, for agents, we need to build our tools. So that's something we're gonna do right now, and afterwards I gotta show you how you're building your agent. And pretty much what we're gonna do in this case, we're gonna build 3 tools. The first tool is getting the information about one specific turbine if they're gonna be default. So we're gonna leveraging our endpoint, which we created here. Then we also want some turbine specifications, so what location, other information about the turbine. That's something we're gonna build here. So here we're gonna need some transactional system at the end. And then we're gonna have some maintenance guides, the PDFs which we saw in the beginning, where we're gonna need some embeddings and a vector search engine at the end to have like textual questions also integrated into it. And how we do it? So generally you have two options. You can also do it in the UI. Here we're gonna do it a little bit coding-like, and basically we have something called functions in this case. So here we are creating a function for our turbine maintenance predictor. Very important, we have here function AI query, which allows you to use SQL to call our endpoint in this case, to do interference with machine learning models, but also generative AI and foundation models, so pretty much any model you have. So that's what we're doing here. Once we're creating the function, if you're gonna jump to our catalog here under functions, we see that we have our maintenance predictor and also the other three functions which already created it, and we were testing them with some simple data. We in this case get okay for those information, it's okay, so no maintenance or no potential error. Then we have our retriever function. What are we doing here? Basically, we're using here in our code to create a so-called lake base. So if we gonna jump over here on a compute, you're gonna see we created a lake base. It is called IoT database instance. On that, once it's loading, we could also add it as a catalog to our Unity catalog, which we didn't do here. But on that, we are syncing a table with a managed pipeline to have a transactional system at the end. And based on that, we are building our retriever. You can see here we have a managed declarative pipeline doing the incremental loads into the lake base. And here we have a sync table, which we are leveraging. And you see that this is not a Delta table anymore. It's a PostgreSQL table as a source. So jumping back, again, we are creating a function. This time the turbine specification retriever, we're getting a turbine ID, and then we get all the information about the current state of the turbine. So our third tool created. And now the little bit more complex one is our turbine maintenance guide. So basically, we are creating here our table, which we want end weight of a component name, and a full guide about the specific components. And what you're using is another AI function, AI parse document, which helps you to parse documents from any PDF files and also other formats. And so we are putting here our volume where the files are coming in. Then we do leveraging some other AI functions to do the transformation. So first of all, we spill out, process the data. I don't want to go into details now on this level. And at the end, using our AI extract function to extract specific information out of the text we have in the document. We're getting this nice structured text with EAN, weight, component name, and the full guide. And based on that, we are creating a vector search endpoint. Again, you can also create this manually. So here we can see the vector search endpoint was already created. That's why I had an error. But at the end, we are creating a sync into another table with the embeddings managed using this open source model, which we make available on our site. And then again, we are creating our tool. And just to show you as an example how you're getting your vector search. So if you're going to our catalog, So if you go to a table, you can create here your vector search index, you define the primary key, you define the embedding model down here, and that's pretty much it. And so we just did it coding-wise. And so, yeah, well, then afterwards we're creating our function again. And again, here we can call it, for instance, is giving me an error. Please show me the reports at the end which are relevant for that. In this case, we are just getting the last one report. It might make sense to also get the last 3 or 5 reports based on the embedding. And those features now we're gonna use, which are saved in a Unity catalog to create our agent. All right, now I am in our catalog and we can see our 3 functions which created. Our maintenance guide retriever, providing us information about specific text or questions we have to maintenance guides. Then we have our maintenance predictor, predicting if a turbine based on the values might have any issues and needs maintenance. And we also get some information about a specific turbine, current sensor data, location, etc. And so regarding the maintenance guide, we have a vector search or vector index in the background. So if you go to tables, so basically it's a vector index saved as a table, we can see that it's a vector index synced towards this table in the background, which we can directly leverage in our agent, which we're building now. So now, what are the options to build an agent on our site? Basically, once you created the tools, you're going to the playground over here. I already jumped in there and prepared something for us. So basically, first of all, you can choose your foundation model, which we're gonna be using. I chose here GPT OSS, but you can see that you have a lot of other models, proprietary, but also open source models. And also if you want to add any other model, like Azure OpenAI, for example, which are not directly provided by Databricks, you can add them free of charge. And well, at the end, leverage the same interface to build up your agents. So we're gonna stay with this endpoint. The second thing you have to do is you have to add your functions and your vector search index here. And of course, the third thing is you need a system prompt. So pretty much the instructions, how the agent should behave. So in this case, it should act as assistant for the wind turbine maintenance technicians. And with that, you can ask questions. So in this case, I moved forward the same questions we had before into our vector index. So we have like a tool and an error, and well, give me some information about it, how to repair it. And here we really get a step-by-step troubleshooting guide based on the documents it identified in our vector search index. So and now we want to build an agent which is gonna be reusable. So here we have the option to create our agent notebook. And well, basically you just do one adjustment defining in the very end your let's see where it is, your schema, where the agent gonna be saved as a model. If you want to refine it and evaluate, you can also, of course, do it. I already did it. You can also see, once you're testing it, that you can see all the MLflow supported tracing. I don't want to deep dive in this part on it. And once you execute it, you well, gonna deploy again another model into Unity catalog. And what are we doing with the models? Technically here now, code-wise, we again creating an endpoint. And so this endpoint we're gonna find again under serving. You can see it's now ready for us, and we can go to the playground. In this case, we are choosing this model immediately, and we can now ask, for instance, the same question. Yeah, it would now use the tools without any setup. And now we can also build an app on it or use a REST API or interface for any other applications to basically leverage this agent further. So, and based on that, we now saw how simple it is to build up your agent. And we now, as a mechanic, have the option to use an agent, ask questions, and really help us to maintain our turbines and identify also issues, as we also added the tools about predicting issues in specific turbines and so on. And this makes the whole maintenance work at the end more efficient, so that our energy company here now, a turbine farm company, really can keep a high maintenance rate and a high running rate on the turbines, and at the end also increase the revenue at the end. Something I want to show shortly, just show you currently in beta, is also Databricks. So another option you can also use to deploy your agent is this way. In this session, I don't want to deep dive into it, but pretty much you can here easily adding other agents or also functionalities. So it's at the end a multi-agent supervisor with which you can also build it in a more managed way without having like the coding way. And then this agent also chooses in the background the most efficient model for your use case again. So it's a more convenient, a little bit less technical way in building agents, which also allows also more business users to build their own agent, productive agents, again, in a very efficient way. So now let's move into the world of a data analyst. So what we said is a data analyst usually lives in this area. And so, well, what he also wants to do, first of all, is discovering data. Maybe he's doing ad hoc analytics, or he's creating a dashboard on top of it. What we here have is a table which we had before, with predictions if a turbine has any maintenance issues or not. And well, what we want to do first is we want to build an interface, a so-called SQL warehouse, so that our analysts can query the data. So that's something analysts would normally not do. A DevOps engineer would prepare probably some warehouses, but it's also good to have an overview how it works. So pretty much what we're gonna do is we're gonna do a NIC demo IoT warehouse. We are defining here the cluster size, so which size or how heavy are the queries. We're gonna go here with a small one, and here we can also define the scaling. And you can set up when it should be auto-stopping. And we, of course, we choose serverless, which is also our most performant warehouse, which brings also all those AI and performance capabilities, caching, etc., which make the queries at the end quite performant. We are clicking create. We can see, of course, also governance goes through all the product in this case, and voila, we can already see that the warehouse is running. So going back to our table, if you want to do ad hoc analytics, we can go to the SQL editor, or we're gonna create here straight away a query. We are choosing here our warehouse, which we so we are choosing here our warehouse, which we just created. And there we go, attach, and we can run the query and can also leverage the editor to, for instance, limit to 50 rows, etc., or queries. So going back, as we also looked into the insights, before, you can see now the query is also available, and you can see that one query has been run with a limit 100. So now we want to build our dashboard, and I prepared one already for you, but you can see here that we click on dashboards, and then we would be able to create one. I created this one already for us. So in this case, we can see that we leveraged the data about the turbines and the results of the outcome of our prediction model. So we can see where the turbines are. We can see which turbines right now have errors, and then the mechanic can also like go and use our agent which we created before go and maintain the turbines at the end. So, and what we can also do is we can ask questions. For instance, I want to ask how many turbines with a fault do we have? And it should give us the number of 40 turbines at the end. Perfect. Yeah, and that's at the end how an analyst really can, for our business stakeholders, like an engineer who's monitoring the turbine farms in this case, like really create a dashboard and business insights, and even allow text to data for the stakeholders in this case. So that's that's pretty amazing, and also makes the life easier for the mechanics or engineers who are monitoring the turbine farms at the end. So, and the last thing now, what we need to do is we want, run our pipeline in a regular manner. And how we doing it, how we are doing this is we are going back to our pipeline. Here we have our demos pipeline, and we can see that we have here scheduler. So you can see there's already a default job created, but pretty much what we can do here is we can create a simple job. So you can, of course, do it continuously. In my case, let's say we want to simply run this pipeline for now, for the beginning only on a daily basis and refresh the data. We want to inform myself on failure. We go create, and basically in the background, what's happening afterwards is that it creates a so-called job. It hasn't been running yet, but we can simply just run the pipeline by clicking now. And of course, you also have the option to adjust the pipeline. So as an example, we could add here the refresh of our dashboard. You can see also Power BI supported, and refresh dashboard. And we, of course, would have to find our predictive maintenance dashboard, and we'll also need to choose our warehouse, which we just created for refreshing it. And also, if you want to have some subscribers, we save the task and have also here some more option to trigger the pipelines also continuously or based on file triggers. And also regarding notifications, we have here also some more options, like sending it to Slack or Microsoft Teams or any webhook, so that you can process and monitor your pipelines in a simple manner. And we can right now see that our pipeline is also running. And once it's completed, you can also like observe and jump into the job to debug if there's some errors, or to have like the monitoring that the pipeline has been completed. And that's at the end an analyst potentially, but especially also a data engineer, wants to have in mind to really be aware, is something happening in the pipeline. The most important thing is like the things to integrate, to orchestrate, and also monitor, that you can really assure that your data pipelines are running in a stable manner. And you see how easy it makes the orchestration and monitoring process for the people monitoring it at the end. So what I also want to show you is that the demo I'm showing here is of course available for you to install and download. So we are looking here for predictive maintenance. We can find the tutorial here, and then you're basically just going to a notebook and pip install dbdemos and import dbdemos and install the Lakos IT platform, and you choose your tag catalog and schema where you want to have saved all the data and also the pipelines, and then it looks pretty much like that you get a lot of notebooks where you can explore everything in the detail which I'm showing today here. And with that, thanks a lot for listening today. I hope you enjoyed the demo, and really feel free to have a look into the demo resources, check out the demo, deep dive into it, and yeah, hope we're seeing each other soon in another video.